In this video, we're going to talk about how function tables, function rules, equations, graphs, and words all work together to form whatever we need to as we go through evaluating function rules. Okay, so first we're going to use a function rule to complete a table of values. So we're going to evaluate f of x, remember that's our function notation, equals 8 minus 3x for the domain 1, 2, 3, and 4. Remember the domain is our x values. So we're going to do a table. We're going to take the 1, 2, 3, and 4, and we're going to place them in the x value box. We're going to take that x value and we're going to substitute it into our function rule. So where the x is, we put our x value for 1. Then we're going to evaluate that or simplify. So 3 times 1 is 3. 8 minus 3 is 5. So that's how we get our values. We're going to repeat that with the 2. So instead of the 1, you're going to see the 2. Evaluate it and get a 2, and for the 3, and then for the 4 as well. So we have our input values, our domain, we substitute, and we get our range, or our output values. Okay? You're going to complete these two tables on your own. They're on your guided notes sheet. Remember, take your x values, substitute them into your function rule, calculate to get your range or your y values or output. This slide we have a review of how to graph. So if you don't need this, you can skip past this part, but I strongly suggest that you at least think about what you need to do. So how to graph. The independent, where the x values are on your horizontal axis. Your dependent are on your y or vertical axis. So the input and the output values as ordered pairs to plot the point. So here you go. 3, 2. I'm going to start at the origin, go right 3, up 2. Then I'm going to put my point. For -3, -4, I'm going to start at the origin, move to the left 3, -3 is to the left, down 4 to get my output value. Okay? And then I'm going to put my point. Then I can connect them all and extend them to make my line, and then that way I get a general picture of whatever my curve is. Okay, so now that we've had function rules and tables, we've had our review of graph, let's see how everything works together. So here's our function rule, f of x equals 3x plus 4. We're going to have a table, so model it with a table. That means just fill out a table, complete the table, and then we're going to graph it. So the first thing we do is we have to figure out what some x values are. So we're going to pick some domain values, some reasonable x values. Think about what's on your graph. So my graph goes from -10 to +10, so I want some x values that are between there. I've chosen -2, -1, 0, 1, and 2. I like to choose some negatives, some positives, so that I can see where everything is. I'm going to substitute them all, just like I did before. Then I'm going to calculate my y values. Put the x and the f of x together to get my point. I'm going to take those, and I'm going to plot each. So -2, -2 is here, 2, 10 is here, and the other ones are in between. I'm then going to add a line to connect and extend. And that's how you take your function rule make a table of values, and you graph it. We're also writing a function rule from tables of values. So given the table of values, we look what happens to x to get f of x, or to get our y value. In this case, each of our x values goes up by 1, and to go from our x value to our y value, or f of x value, we subtract 2. So to write that as a function rule, we write f of x all by itself is x minus 2. So x minus 2. For table number 2, again, we look and see what's going on from x to y. So we're going to multiply them by 2. 1 times 2 is 2, 3 times 2 is 6. And we write that y, because that's at the top of our second column, equals 2 times x, or 2x. For our third table, again, we look to see what's going on here. Since our x values all increase by 1, we look and see what's going on with our x to get our y. So y equals x plus 2 because we're adding. Okay? Now you try some on your own. There's some on your guided notes sheet. We can also write some equations from word problems, from situations. So in the first one, we're looking at a model computer in Boston, Massachusetts. It's about 20 times the size of a normal computer. So we write a function rule to describe the situation. We're going to define our variables. So we have n as the size of a normal computer. We have f of n being the size of the model. The model is 20 times the size of a regular computer. That's really important information, so we want to take note of that. To write our equation, we have f of n from our total. The 20 times becomes a 20 in front of our n, which is the size of our normal computer. Also, if we have a carpenter buying finishing nails per pound, okay, that's how we measure those. Each pound of nails costs $1.19, so we want to write a function that describes that situation. Define our variables. So C of n is the cost of the nails, n is the number of pounds of nails. And the important information is that the per pound cost is $1.19. We have to remember that per pound means we're multiplying this cost times the number of pounds of nails. So C of n is by itself, and then the $1.19 is multiplied by n, the pounds of nails. Now you try some on your own. There's some on your guided notes sheet. Bring any questions to class.